Hey everyone, welcome to this explainer. When violent weather slams into New England, it's really easy to just think, well, that's just a random bad storm. But today, we're going to focus on exactly why these New England storms actually happen. Because as you'll see, it is definitely not just a localized random event. It is this massive, highly interconnected atmospheric system. And honestly, understanding how the whole shebang works is absolutely crucial to staying safe. So picture this. You've got a Midwestern heat dome hundreds of miles away. But somehow, that exact heat dome is putting New England directly in the crosshairs for severe storms. I mean, how does a weather event happening literally half a country away act as the direct trigger for a massive storm threat in the Northeast? It's all about these invisible atmospheric connections. And by the end of this explainer, you're going to see exactly how all these giant puzzle pieces fit together. All right, let's dive right into Section 1, the atmospheric domino effect, and where all this energy actually begins. To really get why these New England storms happen, we have to zoom way out and look at the macro triggers. It all starts with a heat dome. Basically, imagine a colossal area of high pressure parked right over the Midwest and the Great Lakes. It acts just like a lid on a boiling pot, trapping heat and vigorously pumping immense amounts of energy straight up into the atmosphere. This heat dome? It's the invisible engine powering this entire severe weather event unfolding out east. And this engine is working overtime because before a single dark cloud even rolls into New England, all that intensely pumped-in energy is causing local temperatures to absolutely spike into the 90s across much of the region. The atmosphere is just boiling over with potential energy, pretty much loading the dice before a single drop of rain ever hits the ground. Moving right along to Section 2, steering the storms and the delivery system. Okay, so we know where the energy comes from, but how does it actually travel all that way? It's a very distinct three-step sequence. Step 1, that Midwest heat dome pumps up the energy. Step 2, all that massive amount of atmospheric fuel starts rotating eastward. But Step 3 is the real kicker here, a northward bulging jet stream. Acting like a massive atmospheric superhighway, it grabs that energy, funnels thunderstorms right out of southeastern Canada, and steers them directly into New England. Which brings us to Section 3, the impact zone. We're looking at Tuesday afternoon and overnight. So when and where is this atmospheric delivery system actually going to strike? AccuWeather meteorologists are tracking a moderate risk of severe storms across a pretty specific path. For Tuesday afternoon and evening, the primary risk area stretches from southeastern Quebec down into northern Vermont, New Hampshire, and western Maine. We're talking cities like Montreal, Quebec City, Burlington, and Portland. You guys are right in the crosshairs. Then, as we head into the overnight hours, that threat pushes further south and east into central and southern Vermont, New Hampshire, and coastal Maine. If you're in those regions, you critically need to brace for potentially violent ground impacts. The primary threats we're looking at are damaging winds, large hail, and yes, even the potential for isolated tornadoes. And for anyone outdoors or, say, driving along the I-87 or I-95 corridors, you've got to watch out for falling trees and flash flooding in low-lying areas. The ground level threat here is immense, and it really requires your full attention. Just to put that wind threat into perspective for a second, consider this number: 85 miles per hour. That is absolutely wild. Now, the strongest storms will generally bring heavy gusts of around 60 to 70 miles per hour, which is bad enough, right? But forecasters are warning that an isolated gust could actually peak at 85. That is literally hurricane-force wind embedded right inside these thunderstorms, easily capable of causing significant structural damage to homes and businesses. And that leads us to Section 4, the danger in the dark, what meteorologists call the secondary crisis. Honestly, this is the part that keeps meteorologists up at night. It's the lingering, hidden threat that emerges after the storm has passed. AccuWeather meteorologist Adam Dowdy put it pretty bluntly, saying, "These storms could be strong enough to knock down trees and power lines across the region, and rural areas especially could be without power for an extended stretch." So we aren't just talking about your lights flickering for a few minutes. We're looking at a very real risk of prolonged outages leaving rural communities completely off the grid for days. And this sets up a classic, really dangerous double whammy. Think about it. On one side of the equation, no power means absolutely no air conditioning. But on the other side, you're dealing with extreme heat, with overnight temperatures stubbornly refusing to drop below the low 70s. All that trapped atmospheric energy from the Midwest, it ensures the heat is going to stick around long after the storm actually breaks the power grid. And that specific combination, darkness and sweltering heat, triggers a critical health crisis. Extended outages like this drastically raise the risk of heat-related illnesses, because when you can't cool your home down at night, the human body just can't recover from the daytime baking.
This is incredibly dangerous for kids, the elderly, and anyone who fundamentally relies on AC, quickly transforming a severe weather event into a serious public health emergency.
So because of these compounded threats, immediate preparation is key. First off, actually do this right now while you still have a steady grid. Charge your devices. Second, keep extra batteries ready for flashlights and radios. And third, stay highly weather aware all through Tuesday night. The atmosphere is totally loaded right now, and conditions are going to change rapidly. Which kind of leaves us with one final, pretty big question to think about. When a distant heat dome, literally hundreds of miles away in the Midwest, can trigger a highly specific chain reaction that ends up darkening our New England grid for days, just how prepared are we for the next invisible atmospheric domino? It really makes you think about our shared vulnerability to these massive interconnected weather patterns. Thanks so much for joining me on this explainer. Stay safe out there, stay prepared, and keep questioning how our crazy world connects.